Welcome to EDU World Space.
In this question, we're asked to rotate a very specific curve around the x-axis. The curve is an ellipse, and what this does is it forms a prolate spheroid. So the first thing we need to do is we should remember the formula for the surface area.
Application of
We'll
the
use
work
this
energy
form
theorem,
here. The
wet.
surface area
From the
will
work
be
energy
equal to an
theorem,
integral
the force
from
F is
a
given
to
by
b,
F equals frac
some a
times
to some
KE,
b,
where
we'll have
KE equals
2 pi
kinetic
y
energy, S equals
times
stopping
square root of
distance.
1
I'm
plus
given for
y
object A,
prime
FA equals
squared
frac 100,000, 0.10.
dx.
For object B,
We'll
FB
need both
equals
of
frac
these forms later,
225,
so we'll replace
1500
this
for
eventually with an
0.15
x
text space.
squared, x prime
And force
squared
ratio frac
by,
FA,
for
FB
instance.
equal frac 0.10, 0.15 equal frac
In order
2
to
null
use this
result.
formula, we
On the
have to
box frac
first
FA,
solve for
FB.
y.
Would you like a PDF version of this explanation?
When we do so, just realize you can subtract this x squared over a squared, multiply the whole thing by b squared, and then take the whole square root. So we would have just, so let's demonstrate that in action. You would have 1 minus x squared over a squared, the whole thing, times b squared, which you can then take the square root of. This inside here, we can factor out a squared. If we factor out a squared, we're going to have this is equal to, so it'll be a squared minus x squared times a squared b squared. Or actually, b squared over a squared. All of that in the square root. Oops. B squared over a squared. All of that in the root. And what that gives us is that will give us b over a times the square root of a squared minus x squared. Next, we ought to find its derivative. By use of the chain rule, we'll get that this is going to be equal to, keeping the b over a constant, we'll have b over a times 1 over 2 times the square root multiplied by negative 2x. And obviously, this and this will cancel. So this will be negative bx over a root a squared minus x squared. Since we're only taking the top half, we're going to actually have to double the surface area. So the surface area in this case will be twice the integral from some arbitrary a to b we'll have 2 pi y, which we said was b over a times root a squared minus x squared, times the square root of 1 plus negative bx over a times a squared minus root a squared minus x squared, the whole thing squared, and that will be integrated all with respect to x. Now we have to do a little bit of simplification here. So one thing we can do is we can factor this 4 pi b over a outside. So that would be at 4 pi b over a. And then the integral itself, it would instead just go simply from 0 to a because of how we're doubling. Because remember, for an ellipse, when you have x squared over a squared is its major axis. But the a is its major axis, so we only want to integrate from 0 to a in this case. So we can also combine this in the square root. The square roots can multiply together, so we would have the square root of a squared minus x squared, and we can also expand out the square as well. The square within the square root. It would be 1 plus b squared x squared over a squared times a squared minus x squared. All of this stuff is in the square root, and this will be integrated with respect to x. What we can do then is we can distribute all of this stuff. We can distribute this a squared minus x squared into both terms here. So we'll have 4 pi b over a, integral from 0 to a. We'll have a squared minus x squared plus b squared x squared over a squared dx. Next thing we should do is we should get a small common denominator. So let's multiply both of these fractions. Let's multiply the a squared minus x squared by a squared over a squared. When we do so, we're going to have this is going to be a to the fourth minus a squared x squared over a squared plus b squared x squared over a squared. And again, all of this stuff remains still. Again, which is going to be all in the root. And we can factor out the a squared here. So that will be 4 pi b over, if I factor out the 1 over a squared in the root, it's going to become a 1 over a when I bring it outside the root. So I can move this a squared here. That will mean we have an integral from 0 to a of the square root of a to the fourth minus a squared x squared. But let me write it like this. It will be written as a squared plus b squared times x squared dx. And we still need to do more simplifications here. This isn't all we have to do. Actually, so this plus should be a minus. Oops, I made a mistake there. Should be a minus. And if I factor out a to the fourth again, let's factor out a to the fourth. So we would have this is equal to a to the fourth times 1 minus a squared minus b squared times x squared divided by a to the fourth power. All of that in the root, and all of this stuff is in the root, and when we factor it out and bring it outside the root, this and this will actually end up canceling out. So our integral will become 4b times pi times the integral from 0 to a of the square root of 1 minus a squared minus b squared, the whole thing over a to the fourth times x squared. All of this is going to be in the root. Now, we need to do some sort of trig substitution here in order to make our life a lot easier. So what this means is we have to say x will be equal to, or rather, we're going to let all of this, or rather the root of it, so we'll have the root of a squared minus b squared, the whole thing over a squared x will be equal to, let's say, the sine of t. So let's say x will be equal to a squared over root a squared plus minus b squared times the sine of t. And so dx would be equal to, all of this a squared and b squared terms are constant. So we'll just let that equal cosine of t dt. We might need some things later to come back. Convert back to x. We'll take some arc sines later. So our integral, we're going to skip the bounds for now because we're going to be returning back to x. It's going to be 4b pi, the integral of, we'll have this, all of this stuff here is going to be 1 minus sine squared of t times a squared over root a squared minus b squared times the cosine of t dt. And realize that all of this stuff here becomes just a cosine squared of t within the root, which is then going to become cosine of t. So factoring things out and rewriting this, this will become the integral of 4a squared b pi over the root of a squared minus b squared times the integral of cosine squared of t. And here I'm going to use the fact that the integral of cosine squared using the power reduction formula is going to be, you would have 1/2 times t plus 1/2 the sine, or x, I should say x rather, the sine of 2x. This is just something that is known. You can use a table for that, or you can derive it by hand. It really doesn't matter. So you have the cosine of t. So you have the cosine of t squared. So you have the cosine squared of t, which means evaluating this integral, we would have, bringing this 1/2 outside, this would become a 2a squared b pi over square root of a squared minus b squared. And we would have t minus, let me actually write this 1/2 sine of 2t, or 2x. Let me write it like this. Write it as 1/2 sine t cosine t. And I'm going to ignore the constant for now, even though we technically did an indefinite integral. Now, in order to go back to x, in this case, we're going to draw a right triangle. So there's our angle t. We said that, now what we did is we said that x so the sine of t is equal to x times the root over a squared, which means that the hypotenuse has to be a squared, and the opposite side is going to be x root of a squared minus b squared. So obviously the missing side, by the Pythagorean theorem, would be the square root of a squared minus x root a squared minus b squared, the whole thing squared. All of that is in the root. So we have a little bit of a nested root situation, which would be the square root of a squared minus x squared times a squared minus b squared. Just like that. Or, if you'd like to rewrite things, that's good enough. Okay. Now, so what we're going to have is, we know we have this 2a squared b pi over the square root of a squared minus b squared. And then this t here, taking the arc sine of both sides of this root a squared minus b squared times x over a squared will give us the arc sine. Will give us the arc sine of x root a squared minus b squared over a squared minus 1/2. The sine, we said it's just going to be x root a squared plus b. It's going to be just this over a squared. And this will be multiplied by the cosine, which is the opposite, or rather the adjacent, over the hypotenuse. And actually I made a mistake here. There shouldn't even be this 1/2 here, nor here. So it'll be just like that. And let me actually move this down here, minus we'll have x root a squared minus b squared over a squared. And the cosine, we know that the cosine of t in this case, it would be, doing simplification, it would be a squared, this root of a squared minus x squared times a squared minus b squared, the whole thing over a squared. Doing a little bit of simplification, we can write this as multiplying by the root of a to the fourth minus x squared times a squared minus b squared, the whole thing over a squared. And remember, we need to evaluate this at 0 and a. So let's show that here. X equals 0 and x equals a. Fortunately, we need to be a little bit careful when doing our evaluation, because we can mess up things very, very, very easily. So that would be 2a squared b pi over the square root of a squared minus b squared times arc sine of a root a squared minus b squared over a squared minus a root a squared minus b squared over a squared times root of a to the fourth minus a squared times a squared minus b squared over a squared. Subtracted from the same thing over square root of a squared minus b squared times the arc sine of, plugging in 0 now, we'll have just the arc sine of 0, which is 0. Arc sine of 0 minus 0 minus 0. So actually, we don't really care about this entire second term here. Everything becomes 0. And doing all the simplification here, you can cancel out this. Actually, close this parentheses there. Doing all the simplification, canceling out a's, you'll have an arc sine term here, multiplying out all of the roots. It will give us a final answer of 2 pi times a squared b over root a squared minus b squared times the arc sine of square root of a squared minus b squared over a. The whole thing will be added with b squared. So that's how you do that part. Now the second part asks us to rotate it about the y-axis. In that case, we would need to use a slightly different formula. Instead of solving it for x, instead of solving the ellipse formula for x, we're going to solve it for y instead. So let's write down the formula again. X squared over a squared plus y squared over b squared is equal to 1. So by solving for x, what that means is we would have x doing basically the same thing as we did. We would have it as a over b times square root of b squared minus y squared, which means that x prime as a function of y, keep in mind that, would be equal to negative a times y over b root b squared minus y squared. Now we know that a is larger than b. So what that does is our integral, we can't really swap. we can't really swap this around. So our integral would have to change a little bit. The integral, when we rotate it around the y-axis, in this case, would be an integral from 0 to b. Keep that in mind because we need to do this. It would be 2 pi times the square root times a over b times square root of b squared minus y squared times all of this in the root of 1 plus negative ay over b times root b squared minus y squared dy. The whole thing is squared. Now, this is almost like the last part. So we got to do a little bit of a different strategy here. The first thing we'll do is we'll bring the a and b and the 2 pi outside. So we'll have 2 pi, 2a pi over b. Let me actually write that a little bit better. 2a pi over b times the integral from 0 to b, and we'll have the square root of b squared minus y squared times 1 plus a squared y squared over b squared times b squared minus y squared. And all of that will be integrated with respect to y. Multiplying this across, we'll get that this is equal to b squared minus y squared plus a squared y squared over b squared. And actually, don't forget to multiply by 2 because we're integrating only from 0 to b, which is the minor axis. So the integration work is going to be pretty much identical. So we're going to skip to the end of the result. So after all the simplification in trig sub, what you're going to get is you're going to get that this is equal to, or if you use a calculator, which I did, you're going to get this is equal to 2 pi a squared plus 2 pi ab squared root over the root of a squared minus b squared times the natural log of a plus root a squared minus b squared over b. And that's the answer for this part here. That's how you do this question.